This is Robert Kraft, and I'm your host on SNN Network. And joining me right now is Andrew White. He is the CEO of CHAR Technologies. It's a publicly traded company. The symbol is YES, Y-E-S on the TSX Venture. And CHAR Technologies will be presenting at our upcoming virtual event, the SNN Network Canada virtual event happening December 7th through 9th, 2021. For more information to register and see that presentation, please go to canada.snn.network. And with that, Andrew, thank you so much for joining me today. How are you doing?
I'm great, thanks. And thanks for having me, Robert.
It's great to have you. So this is our first time doing an interview together. So can you start us off with a quick overview and history of the company?
Absolutely. So, high level, CHAR Technologies is a clean tech services and technology development company. We do have some work in environmental compliance, and really that builds into our technology portfolio where we can, support technology development. The core of the business is a technology called high temperature pyrolysis, where we take one of three waste streams, biosolids, digestate, and compost, digestate being the leftover from a standard biogas, renewable natural gas plant, or woody biomass. And we convert those products into biochars and biocarbons, things like coal replacements and soil amendments, as well as renewable energy in the form of gas. That gas we can extract as green hydrogen or renewable natural gas.
Very good. So what would you say makes CHAR Technologies unique and different compared to some of your peers out there?
Yeah, there's a couple of differentiators. First, if we look very tightly at thermal processes, you've got what's called gasification, you've got what's called high temperature pyrolysis. And the core of what we're doing is we're going high temperature, so think like 850 degrees Celsius or 1600 Fahrenheit, and we're going zero oxygen. So this gasification technology does include a little bit of air. And by having zero oxygen, flame doesn't touch our product, it's heated externally. We thermochemically convert our feedstocks into this solid carbon and this gas. And we're able to create a very clean, consistent syngas, which is crucial for taking it to that green hydrogen or that RNG space. We also have a modular approach. So, our kilns, our biggest one process is about 3.5 tons per hour of feedstock. To put that in context, if we're running wood, that would make about 250,000 gigajoules a year of renewable natural gas. And we want to expand, we build 2 or 3 modules. So we can build a plant for pretty low CapEx, get it cash flowing, and then expand it. Or we can build 4 modules right away, but those are all factory built, factory acceptance tested, standard equipment, so that we can keep a lot of the on-site construction commissioning risks to a minimum.
So follow me on this one. So on Twitter, there's a trending theme of like, explain this to me like I'm 5. Now you're in an industry where I'm sure you get a lot of geniuses like me that say, hey, can you explain exactly what you do like I'm 5? What exactly is the problem that you would say CHAR is looking to solve? And again, I apologize for everybody out there who is very well versed, not just in CHAR, but maybe this industry, but for those who may not understand about pyrolysis and biocarbon development and how organic waste is then developed into natural gas, renewable energy. Explain the problem that's being solved here.
Absolutely. So at a high level, the explain it like I'm 5 Reddit subreddit. What we're essentially doing is both renewable energy and waste reduction. So when we look at those 3 kind of feedstock market verticals, we talk about woody biomass. And what we're taking is things like bark, sawdust, stuff that forestry operations sometimes face a challenge getting rid of. Sometimes it's a cost, it has to be trucked far away, maybe it has to be landfilled. And landfilling woody biomass, I don't think is a great use of a resource. It's not very sustainable. So in that market vertical, we're solving this issue of we're not utilizing this resource very well. On the other side, the output, the renewable natural gas, the demand for renewable natural gas is enormous. a recent report I looked at for Fortis BC, the gas utility in British Columbia, they've got a mandate of about 15% of their gas grid to be renewable. To do that, they need on the order of 40 pentajoules of energy. Pentajoule is just an energy unit. It's 1 million gigajoules. Gigajoule for those in the US is pretty close to 1 million BTUs. Just it's a 0.9 conversion factor. So they need 40 pentajoules. Canada produced 6 in 2019 across the entire country. So the demand and the need for renewable natural gas is massive. The other piece on that is the gas utility in Quebec commissioned a study that showed over 80% of renewable natural gas to meet their targets would have to come from woody materials like ours. So on the woody biomass vertical, it's solving those two problems. On the digestate, which again is, think of it like compost coming out of a biogas plant. It doesn't have a lot of value. And in a lot of instances, it's a liability. It's a cost to get rid of. So again, waste reduction, we're processing that material. So it doesn't have to, you don't have to pay to get rid of it. And we're creating 2 products. So our project in California with Hitachi Zosen and Nova is exactly that. We're processing their digestate they're making, creating biochar and creating green hydrogen. So waste mitigation and then actually turning it into valuable products on the other side.
All right, there we go.
I don't know if a 5-year-old would have stayed for that whole explanation, but hopefully I broke it down for you.
Don't worry, my 5-year-old brain was following right along with you, so I appreciate that. So Andrew, I also want to know about your background. How'd you come into all this?
Absolutely. So the kind of starting technology was something I developed with my professor at the University of Toronto. I was finishing my master's in chemical engineering. And we actually went out and did a site tour of a biogas plant, saw all of this digestate being built up. If anyone's been to a biogas plant, you know that digestate tends to have a bit of an ammonia smell to it, stronger some plants than others. So we threw some in a garbage bag, threw it in the back of his CRV. For those of you who know his Honda CRV, the trunk is connected with the passenger cabin, and took the 2-hour smelly ride back to Toronto, went in the lab and found a way to process this material to create some of these value added products. The focus of my research was creating higher value biochar out of it, and that evolved into the gas. Launched CHAR in 2011 after initially filing some patents, and we've been running kind of ever since, growing. In 2016, we went public through a qualifying transaction with Cleantech Capital. 2018, we acquired consulting engineering and technology firm, and we commissioned our first pyrolysis plant. So that's the real condensed history.
Very cool. All right. So then before I let you go here today, but from what you can tell us, what would you say are some of the company's value catalysts going into 2022?
Yeah, and really it is those 3 market verticals. So on the woody biomass to RNG, the projects we've announced and we are continuing to develop is all around build, own, operate. So we're getting nice long-term utility grade returns on the outputs on the RNG. On the anaerobic digestate front, because we are solving a waste issue and creating green hydrogen in places like California, we certainly expect to see projects continue to develop in that space. We're helping our partners with a competitive advantage by better managing the back end of the plant. And in the biosolid space, which we didn't talk too much about, but that's very much a equipment sale model versus the build, own, operate on the wood to renewable natural gas, because it's a much more evolved market. And the big issue we're solving there is the destruction of PFAS, these forever chemicals. For those who aren't familiar with it, go check out the movie Dark Waters or the documentary The Devil We Know. It'll scare the hell out of you about PFAS. And we've been working with some of the majors to show that pyrolysis effectively destroys it. So those 3, and of course, the key is this is all still with the same modular kiln system. So we're not building custom design plants here, there, and all over the place. This is the same kiln, the same size, and being able to deploy that rapidly, I think, is the real catalyst that we have.
Very good. All right. Well, Andrew, with that, where can our audience go and find more information on CHAR Technologies?
You can always check us out on the website, chartechnologies.com. We've got a nice video of our plant in London, Ontario, shows how pyrolysis works and kind of gets a better feel for it. We're on Twitter at CHAR Technology with a Y. I don't know who took CHAR Technologies, but sometimes you got to do what you got to do for the Twitter handle, and of course on LinkedIn as well.
Very good. Andrew, thank you so much for joining me today. I really do appreciate it. Good luck, stay safe, and I look forward to our next update.
As do I. Thanks a lot, Robert. Thanks so much.